As we've seen previously, these limits on our integral correspond to a circle of radius 1 centered at 0, 0, 1. 1 unit above the xy plane centered along the z-axis. And we're looking just at the first octant of that circle. Just want to look at the mechanics of the integration, which are very similar to the previous example. We integrate with respect to z. We get the integral from 0 to 1, 0 to the square root of 1 minus x squared. Antiderivative of z is just, antiderivative of constant is just z. So our first integral just consists of z evaluated between the limits 1 minus the square root of 1 minus x squared minus y squared and the square root of 1 plus the square root of 1 minus x squared minus y squared. I'm going to need to repair that. Okay, now this reads correctly. And then that expression to be integrated with respect to y and then with respect to x. This gives us integral from 0 to 1, 0 to the square root of 1 minus x squared of this expression minus this expression. Now, it should be clear that this expression minus this expression is just double the square root. So that should be the integral of 2 times the square root of 1 minus x squared minus y squared with respect to y and with respect to x. Now we can make our substitution. We can let y equal the square root of 1 minus x squared times the sine of theta or the cosine of theta. So that dy equals negative square root of 1 minus x squared sine theta d theta, etc. The identical steps that we used previously, and I'm not going to write those steps out again. Just indicate that our final result, when we get through all the integrations and substitutions, is going to be 2, if we factor out the 2, multiplied by the pi over 6 that we got when we integrated just this expression. And of course that's pi over 3. Now why does this make sense? Well, the sphere described here lies 1 unit, well, the center of the sphere lies 1 unit above the xy plane. The radius of the sphere is 1, meaning that the sphere essentially rests on the origin. And if we look at the region in the first octant, where, let's say, x is greater than 0, y is greater than 0, and z is greater than 0, well, z is greater than 0 at every point of this sphere except for the origin. And the origin has no volume, so that what we're looking at when we look at the part of the sphere in the first octant is no longer 1/8 of the sphere, but rather 1/4 of the sphere, twice as much as we had before. So to make the statement that this sphere lies above the xy plane, with 1/4 of the sphere in the first octant. In the previous 1/8 of that sphere was in the first octant. So that we have twice as much volume in this case.